In our last seminar in geometry, we're going to be looking at two-way frequency tables. And what we're going to do is we're going to construct them, and we're going to interpret them, and we're going to determine if our variables are independent. So a two-way frequency table is exactly what we've been doing all along with algebra and everything. We make a row and columns and we fill them in. So in this case, we're comparing men and women and whether they prefer to shower in the morning or in the evening, and we just fill them in. Now, I could take and find the joint frequencies if I would just divide by the total. And a lot of times what we'll do, instead of writing the fraction, we'll write the decimal. So for example, in my first row here in first column, that's 98 out of 220. We'll write 0.45 if we were doing that. That's usually how you see it written. We just divide by the total for each of them, but I think I wanted to explain what we get there. Then, to be independent, we know from the beginning the probability of A and B equals the probability of A times the probability of B. To be truly independent, you can think of it this way. The probability of A then equals the probability of A and B divided by the probability of B. We'll use the conditional probability to show if they're independent. Now on the first one, an example, we're just going to fill this in. We have Cutler. He asks a random sample of 140 upperclassmen at his high school whether they prefer eating at breakfast or at home. And or breakfast at home or at school. He finds that 55 juniors and 23 seniors prefer eating breakfast at home. So we can fill that in. So we have 55 juniors and 23 seniors prefer eating breakfast at home before school. Okay. Well, 12 juniors and 50 seniors prefer eating breakfast at school. Now I want to organize this into a two-way table, which I've already done part of it. So now we'll just find the totals. We know we have 140 here, don't we? And then we call them row totals and column totals. So my column totals, I'll just add them up. So I'll get 78 people like to eat at home, and 62 like to eat breakfast at school. Notice if I add 78 and 62, I get 140. There were 105 seniors, and there were 35 juniors. And so now I'll fill that in with my relative frequencies. So we're going to say 55 divided by 140. I'll get 0.39. And then 23 divided by 140, we get 0.16. If I add them together, I should get 0.55. And notice if I take 78 divided by 140, I should get the same answer. I guess it's 0.56 if I round. Okay. And then we'll take 50 divided by 140, and we get 0.36. 12 divided by 140, and we get 0.09. And then we'll get 0.45, won't we, as our column total. Then if I do my row totals, I should get 1 here for the total because that's 100%. So 36 plus 39 gives me 0.75. So I should get 0.25 here, shouldn't I? And there are your totals. Now let's take a look at example 2. We have Isaac. He polls 240 of his friends on social media. And about what grade they're in and whether they prefer EDM or hip hop. He posts the results of the survey in the table. Use the table to determine whether a respondent's musical preference is independent of their grade level. So we're going to take a look at our grade level here. And so what we're going to do is we're going to find, let's find this. Let's find the probability that you prefer EDM. Let's use EDM. Well, the probability we prefer EDM, notice there's 116 people who said they prefer EDM. And that's out of 240, isn't it? So if it take 116 and I divide that by 240, we get 0.48. Now, how about what's the probability that you like EDM given that you are a freshman? So we have 100 freshmen prefer EDM, and there are 207 freshmen, aren't they? So if I take 100 and I divide that by 207, notice I get pretty much the same answer. These two are the same. So that tells me they're independent. It doesn't matter what grade level you're in. Your music preference is independent of your grade level. That's how we tell that. So we have to see if they're the same. The probability of A is the same as the probability of A given B is what we're saying. Now, if we take a look at example 3, we have Torrance posts a question online forum about the originality post of a site. And of the 55 respondents who have posted viral memes, 27 photos and 15 photos were not of original content. So let's fill that in here. So we have a total of 55 people in days. Not working out very well there. And then 27 photos and 15 were not original content. So my original content column is going to be 27. Make this bigger, and 15. So we have, 42 are not original content. Now let's look at the original. 3 photos and 10 videos were of original content. So we have 3 and 10. So we have a total of 13. And then we have 30 and 25, which gives us 55. Now we want to put that in terms of our relative frequency. So I'm going to end up dividing everything by 55. So 27 divided by 55 is 0.49. 15 divided by 55 is 0.27. 42 divided by 55 is 0.76, which is what I get when I add them up. 3 divided by 55 is 0.05. So then I'll get what, 0.54. 10 divided by 55 is 0.18. So if I add 27 and 18, I'll get 0.45. Should be 0.46, I guess. But I'll put 0.45. Maybe it's 0.55. Yeah, it was 0.55. Sorry about that. Didn't look at my thousandth place. And I'll get 0.23 here. And once again, that doesn't add to 1. It adds to 0.99, but that's because of rounding. And let me check. Yeah, the 0.05 is right, and the 10 out of 55 is 0.18. That's right. Must be just because of rounding. Now, I got my relative frequency table. Find the probability that a viral meme on the form is not original content, given that's a video. So I want to find the probability that it is a not original, given that it's a photo. So what I'm going to do for my sample space, I'm going to look at my photo row. Notice my photo row is 25. And then what are those not original? That would be 15 out of 25. And if I take 15 divided by 25 divided by 5, I get 3 out of 5, or 0.6, or 60%. To tell the truth, I don't know why we want to use the relative frequencies to do that, but your textbook might ask you to do that, so I went over it a number of times.